A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians, welcome back to another video. Yay, finally an English video. Please ignore the German ones if you're not interested. They are for my students because I'm on parental leave at the moment. Our son has been born on Christmas 2025. So yeah, I still want to teach, and so I do here on this channel. So simply ignore those and then everything's gonna be fine. Today, I'm going to talk about something short and sweet that I see popping up on, for example, X from time to time. It's about this only 1% of people can solve this blah 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 question in 30 seconds. So it goes something like this. In a room, there are 99% left-handed people. How many left-handed people do you need to remove from the room such that the percentage of left-handed people in the room is going to be 98%. This is like the statement of the problem. You probably saw it here on screen, the exact one, and it's probably on the thumbnail. So I give you 30 seconds to solve this in your head, and once you're done, keep watching the video. Done? Okay. Let's continue. By the way, this video has been sponsored by the wonderful people over on Brilliant. More information at the end of the video. And after that, there are going to be two more interesting percentage things that you might or might not know about yet. So let us look at that statement. So let us just suppose that there are 100 people in this room. If there are 99% left-handed people in there, that means there are 99 left-handed people in there and only one right-handed person. Now, what is going to happen if we now take away an X amount of left-handed people such that we have 98% of left-handed people left? Now, you maybe need to shift your perspective away from the left-handed people and over to the right-handed people. We are in a room with like 100 people. If there are 99 left-handed people, then that means there is one right-handed person in there. And this right-handed person, the single one, is going to be preserved. Now let's just think a tiny little bit. If we reduce the percentage from 99% to 98%. Now let's just imagine we still have 100 people in that room. If we still have 100 people in that room, that means we have 98 left-handed people and 2 right-handed people. Now think back, we are going to preserve the number of right-handed people. So this amount doesn't change. So the analogy really doesn't work out quite like that to think about 100 people yet again. But what we can do is, if we shift our focus a tiny little bit to 2%, which basically constitutes the amount of right-handed people. This is written as 2 divided by 100. And now here is where everything becomes really clear. 2 divided by 100 is the same as 1 divided by 50. And this is exactly what we need to know for the statement to work out, or for this problem to work out. If we have one right-handed person out of 50, that means that there are 98% left-handed people left, obviously, with a percentage of 98 divided by 100, or if we just cancel out on the top and bottom and 2, we end up with 49 divided by 50. So 49 out of 50 people are now left-handed. That means 1 out of 50 is right-handed. So in order for us to actually get from 99% to a 98% density of left-handed people, we need to remove, in a room with, let's say, 100 people, we need to remove overall 50 people to get to 94 people overall. So this is basically what you need to do here. Okay, so this covers the first problem, and maybe you got the solution correct. Now, what I also wanted to talk about are 2 more percentage facts. By the way, tell me in the comments if you got it right. So this is a percentage fact that you probably ran across in the internet at some point in time. So if you want to find out, for example, 12% of 75. Well, this right here is kind of hard to solve, because what you would need to do is you need to convert the 12% into a decimal number, so 0.12, and then multiply it by 75. This is what it means to have 12% of 75. But let us think differently in a matter of hundreds. Basically, this is what percent means, per 100. So this right here is equivalent to basically saying we are going to take 12 hundredths of 75, where of means multiplication. And now it becomes clear what we could also do. Since multiplication is commutative, what we can do is we can take the 1 divided by 100 and just move it over here. And instead ask the question, what is 75%? So 75 over 100 of 12. And this makes it way easier because 75% is the same as 3/4. And 3/4 of 12 is nothing other than, well, you guessed it, 9. So the solution is 9. That's a nice trick that you should just keep in mind. Of course, there could be stupid situations like 33% of 32. I mean, this really doesn't make too much of a difference, okay, if you do it one way or the other. But for things like those, this actually works out nicely and is a splendid way to calculate stuff like this in your head fairly easily. Now, the last thing I want to talk about is an exercise that I do in 12th grade when we talk about limits. And we are just going to suppose something. Suppose something has a price of $100, okay? Something is $100. And what we are going to do is, so here's like a standard thing you find in percentage calculations. You are going to reduce the price by 10% and then raise it by 10% once again. What is the price now of the product? Let us just go through this real quick. So we are going to reduce the price by 10% of this. It's like on sale, for example. So if we reduce it by 10%, that means there are only 90% left of $100. So that means times 0.9 leaves us with $90 overall, if we take the units. Now, what we also want to do is we now want to raise the price by 10% once again. So we take the $90 and we are going to raise it by 10%, meaning this is the original price times plus 10% of the $90. So that means we multiply it by 1.1. Multiplying this by 1.1, this is going to leave us with $99 overall. So what you are going to notice is it doesn't work like that. That's like a question that you just like to tell your students about. If you lower the price of something and then raise it once again, you are going to end up, for example, with a discount. It just doesn't go back to the original price once again. Why is that the case? Because if you lower it by 10%, that means you are going to end up with a lower value than the original one. And 10% of the lower value is obviously not the $10 that you started with, that you subtracted, meaning you are going to end up with a lower value overall. And here you could ask yourself the question, and this is what I did a few years back. What happens if you do this indefinitely? One after another, you raise the price and then you lower it again, or vice versa, lower the price and raise it again, and so on and so forth, infinitely. So what we are going to end up with is we are going to suppose that our price is once again $100. This right here is our price. And what we are going to do is we are going to lower the price by P. Okay, P could be 0.1 or it could be 0.5 or whatever. And then we are going to raise it by the same amount once again. So what we are going to do is on the first step, what we did is we multiplied it by 0.9. So we started with 10%, which is 0.1. So in order for us to get to 0.9, we need to take 1, so 100%, and subtract the 10% from it. So we are going to multiply it actually by 1 minus, and let's just call it P for percentage. This is what we do. Really doesn't matter what the percentage is. And now we are going to raise the price by the same percentage once again. So in order for us to raise the price, we are going to multiply it by 1 plus this P. So multiply it by 1 plus P. And now you are going to notice something. Namely, this right here is the difference of two squares. This is going to end us up with 1 minus P squared, where P is strictly between 0 and 1. And we want to do this infinitely often. So from this $99, we want to raise the price by 10% once again and then lower it once again. Really doesn't matter how you turn it around. It leaves you with the same with the same result overall. Just because, as we talked about before, multiplication is commutative. So what we are going to do is we do the same process once again. So we are going to multiply by a factor of 1 minus p squared on the second iteration, and then on the third, and so on. So what we are going to end up with is overall, we are going to take our $100, I'm going to leave out the units for now, and we are going to multiply it by 1 minus p squared, but we are going to end up with an nth power because we are going to do n iterations. But if we do it even more extreme and take it to its limits, and I mean it to its limits, then we are going to take the limit as n approaches infinity. You got infinitely much time on your hands, many time whatsoever, much time. And you do it, okay? You just do it. You do the limit as n approaches infinity. We can do some limit analysis here. Now, if p is between 0 and 1, what does that mean for 1 minus p squared? This just means that we subtract a number which is below 1. So if you square all of those factors that you got right here, you are still going to end up with the Euler relationship that p squared is between 0 and 1. Meaning overall that this p right here is gonna just be positive overall, and 1 minus p squared overall is gonna be less than 1. So this thing right here overall is once again between 0 and 1. And if you raise something between 0 and 1, for example 1/2 to the nth power, then you are going to end up with 1 divided by 2 to the n. And if you take the limit as n approaches infinity, that is 1 divided by infinity, overall going to 0. And this is the same argument that I brought up before. If you lower it and then raise it once again, you are raising a lower value than that, and you are going to end up with a lower value overall. And in the limit, this is always going to be the case. Always you are going to end up with 0. The only cases where you don't do so is by a 0% increase or decrease in price, or a 100% decrease or increase in price. So I hope you did enjoy what you have seen today. Those were just 3 curious percentage facts that I wanted to show you guys here today. And if you want to see more quizzes, puzzles and percentages, then the contents of today's sponsor Brain might be the perfect fit for you. If you like what you have seen today, then you are going to enjoy Brilliant by a huge margin too, I promise you. With their over 70 interactive courses in all topics STEM, be it the mathematics that we did today, physics, computer sciences, they give you the best online learning concept that you can find out there on the World Wide Web. All their courses are underlined by those nice graphics and interactive things that you can play around with. Interested in seeing how the limit behaves graphically, for example? Doesn't matter. Check out Brilliant over on their limit course and calculus courses. They got a bunch of visualizations for limits and how those points are going to converge, for example, to a certain number. It's amazing. You should just see for yourself how cool it is by checking out any of their courses. And the cool thing about Brilliant is also, if you are a new subscriber to the services, they ask you where you are in your studies right now. Are you a beginner? Then they are going to provide you with beginner courses. Are you more advanced? Well, that is not a problem. You are already at university. They are going to provide you with the perfect courses at your intellectual level right now. So why not try it out today and see for yourself if Brilliant is something for you by using my link here at the top of the description, brilliant.org/maths. With it, you are going to get a 30-day free trial of amazing awesomeness. I still can't believe that they offer such a long trial where you can try out everything to your heart's content. And if you think like this could turn into a long-term relationship between you and the services, then why not make sure to use the link in its entirety and get 20% off an annual premium subscription. 20%, that's a 1/5 decrease overall, which is awesome. It's seriously a steal, and your brain is just gonna enlarge by 50% because of all the knowledge that you can gather over on their courses. They provide a cool service to the STEM community, and I can't recommend them enough. Check it out for yourself and see if it's something for you, and I would appreciate it if you would try it out. It would support the channel a lot. And other than that, I thank you guys for watching, and up until next video, I wish you guys a flammable day. See ya!